This is Aaron Murakami, and today is Monday, September 29th, 2014, and it's 10 o'clock in the morning Pacific time. And today on the call we have with us Mr. Eric Dollard, and this is an invite-only call, only to people who actually have a copy of Eric's recent presentation, which is the Extraluminal Transmission Systems of Tesla and Alexanderson. And it's by invite only because that's kind of the topic that we wanted to cover any questions. And then after we just kind of stick to this topic, then we can kind of branch out into other non-related topics. And so, Eric, can you hear me okay?
Yeah, everything's kind of weak, but I can make sense out of it.
Okay. And so now there's another Eric on the call, and you said you already had a couple questions. If you want to go ahead and ask those, Eric can take it from here.
Okay, well, I guess the first question I was going to ask is, what exactly is induction in your eyes?
Did you ask what induction was?
Yeah.
Induction is the ether being polarized by electric forces.
So it's not simply the change in field over time?
I'm having a kind of a hard time understanding. Can you hear okay, Aaron?
Eric,
can you repeat the question?
Speak up a little bit. Yeah.
I was asking if induction was not then simply the change in field over time.
The change in field over time, that introduces something else that's related to the induction, but that's not the induction itself, not by the definition that I use in my writings.
Okay.
Eric, would you mind
Eric,
would you mind elaborating a little bit more on your answer there? I don't quite understand the difference between induction itself in your eyes and it's not simply a change in the field over time.
No, the induction is the field. So if induction is changed with time, then that introduces either an electromotive force or a displacement current, which is not the induction, but the rate at which the induction is produced or consumed.
Oh, thank you.
Okay. Yeah, and if anybody wants to ask a question, go ahead and just say your name and where you're from, and go ahead and ask your question.
Are we still on the topic of the Tesla transluminal transmission, or are we moving on?
Yeah, we're still there.
Yeah.
Okay, so I'll just wait because I have some questions, but they're kind of outside of the scope.
Okay. Well, is there anybody else on the call that has questions specific to the recent presentation? Because in that presentation, it was about 4 hours long.
Go ahead if nobody does. So you talked about a dielectric transformer in the context of displacement current. Does that simply mean putting a small capacitor next to a big capacitor and then getting the equivalent of putting a big coil next to a small coil?
Well, no, not necessarily. It's the displacement current is a result of the capacitor either accumulating the charge or getting rid of its charge. So the charge is the displacement current multiplied by the time over which it acts.
So what would a dielectric transformer look like then?
It's usually a stack, like a chain of insulators, strain insulators, or suspension insulators, or it could be a Tesla transformer, where the dielectric field activates about as much energy as the magnetic field so that they're balanced, so it's not simply a magneto-type transformer, but now it's a magneto-dielectric transformer.
Interesting. And again, if anybody else has questions, I don't mean to monopolize the conversation. Go ahead and ask.
Oh, Eric, this is Patrick from the Bay Area. I just wanted to thank you for all your time and effort and quite frankly the love that you put into your work. This is fantastic. I just wanted to thank you. I know you had to summarize a tremendous amount of information and kind of make it translatable to us regular people. Thank you for doing that. My question is, you talk about the displacement current, and you say it does not produce a magnetic field.
Well, that's still up to debate whether there's a magnetic field associated with it or not. I think that there's a situation in which it does not produce a magnetic field, but that would have to be determined by experiment.
Okay. Because my question was, how can it be a current and not produce a magnetic field?
Well, the thing is currents don't produce magnetic fields. Magnetic fields produce currents. And the current that you're referring to with the magnetic field is atomic. It's inside the metallic structure, so what that current is a reaction that confines the magnetic field so that it can't get into the conductor, but the magnetic field slowly soaks in, and then the current basically becomes uniform through the conductor, and then it's like a chicken or egg. You can't really separate the two, but the displacement current does not involve material substances directly. In other words, you can have a displacement current in a vacuum, such as a vacuum capacitor, with 40 or 50 amperes flowing through it.
I see.
So the question is does a 40 or 50 amperes flowing through that coaxial cylinder vacuum capacitor produce a magnetic field? That would have to be determined by experiment, but it would be rather difficult because the electrostatic potential involved would be several thousand volts, so there would be all kinds of coupling effects and what have you. But if you had a rod insulator like they use on high-frequency antennas that was made from some kind of real high permittivity material instead of the normal porcelain, if a normal antenna insulator has 5 amps flowing through it in an HF transmitting antenna, then if you increase the permittivity, you can get that up to 40 or 50 amps, providing the power was available to do that, and then you can see if there was a curling magnetic field around that insulator. That would be a very interesting experiment to do.
Yeah.
So if indeed there is no magnetic field with a pure displacement current flowing through a so-called insulator, then that opens up the possibility of a pure dielectric propagation in which the velocity is indeterminate. That's what I mean by extraluminal, is there is no velocity. The light does not enter into the equation.
Yeah, exactly.
The speed of light only enters into the equation when you're comparing between electromagnetic and electrostatic units. But if you're in one system of units or another system of units and you have no need to move out of that system of units, there is no velocity and there's no time factor.
Yeah, because you say the velocity of light is just a coefficient when you're comparing in the two different unit measurements, correct?
Right. Yeah, the velocity of light is not necessarily an intrinsic aspect of electricity. It's a dimensional coefficient to get you from one system of units to the other, and if you're involving both fields in a transverse configuration, then it resolves to an actual velocity. Otherwise, it's a dimensional coefficient. So basically, I'm writing a book to go with this presentation, so I'm hashing all that out right now. I just put together about 100 pages on that subject, which will leak out on the energetic form before it turns into a book.
That's awesome. You talk about the heavy side R, L, G, and C. Is the displacement current the C in heavy sides, R, L, G, and C? Is the displacement current the C?
Well, there's 4 products out of that. But anything that involves C or G is going to be in the realm of the displacement current. So if you have a voltage and a frequency, then in association with capacitance, that's a current, which does not represent the consumption of energy, but if the molecules in which that exist are breaking down, then that is a conductance, and that radiates or produces heat or somehow destroys the energy of the system, then that's the G.
Oh, I see. So you talk about... Oh, sorry.
No, go ahead.
I just wanted to ask you a quick question relating to something that came up earlier. So in your opinion, it's not possible to propagate an electric field or dielectric field through space directly?
I'm not certain about that.
Okay.
I'm assuming that it is, but it's not necessarily known how to go about it. And then there's some geometric complications involved. If there is a propagation of dielectricity, it's not through space, it's through counter space.
So if I put a capacitor next to another capacitor, I wouldn't necessarily get a signal propagating from one to the other.
Well, it depends how they're configured. If you hook them in parallel, then their charge is going to equalize. If you hook them in series, then that's the first step of a radial dielectric transmission structure that has to consist of.
I'm talking about two otherwise unconnected capacitors, using one as the transmitter and one as the antenna, receiver antenna.
Well, the thing is, the capacitor is a lumped deal that doesn't involve any aspect of space externally. So chances are, if you connect them together, it's going to be an electromagnetic transmission with a pair of wires, and that's not dielectric.
Okay.
If you hook them in series, well, then that implies that there's other series capacitors further on one end, and there's another set of series capacitors going out further on the other end, and it's a chain. And that would be a dielectric propagation. That's how it would propagate, is effective series capacities. How that would come about would somehow involve the ether. Yeah, if you have the wire connecting in between.
Wire connecting, yeah.
Okay, I'm not certain now. I've missed a few things.
Okay, what I'm talking about is what you describe. You have one capacitor connected to the next, So you have a Tesla one-wire or telluric system, I think you call it. I'm wondering if you could propagate the dielectric wave through space without any wires involved in the propagation, in the same way that electromagnetic field propagates through space.
Yeah, that's all up to speculation at this point. Exactly how that comes about.
Thank you.
Hi, Eric. Just a quick question regarding counter space and your definition of counter space. Is that the same thing as ether? Just trying to understand what counter space is.
Counter space is, if you measure space in centimeters, you have to measure counter space in per centimeters. So space in a normal sense is the square footage you pay for to the real estate office, but counter space is the space in between the lines of the ruler. So the more lines, the tighter the regular space, which means the more counter space there is. So if you only have two marks on one end of each end of a ruler and nothing in between, there's not a lot of counter space and it's all in space. But if you divide it into millimeters, then there's a lot of counter space, but not necessarily a lot of space. And those proportions are, to look at it that way is really important when you're dealing with the calculation and theory of inductance and capacitance, because you have this row of wires or you have a row of plates, or it's a geometric consideration where you have proximities.
Okay.
So something that would propagate a dielectric wave would be like a bunch of small spheres all separated by a fraction of their diameter in a long line, and then if there's a sudden electrostatic disturbance at one end, the electrostatic disturbance will propagate along those closely spaced spheres as a string of series capacitors. And that will drop off at some kind of hyperbolic function or at an exponential rate, depending upon how much leakage induction there is between the spheres and ground or some other object that's not part of the transmission. So you have series capacitors and parallel capacitors in a ladder network, and that produces a wave propagation, but the time delay is, there is no time delay. It's basically instantaneous. So you can't get a standing wave.
So does all this mean that the electric devices around us, our household appliances, are giving off a bunch of signals we don't really know about?
No, because they're designed to confine the electric field. They're not made to radiate. But if you take a broadcast antenna or something like that, well, that's a different story.
Okay.
So you either have a transmission structure or you have a some kind of antenna structure. So the transmission line basically does not radiate because the wires cancel each other out and confine the field, but if you just have one wire, then it does radiate, and then you're going to have both magnetic and dielectric emanations from it.
Okay. In the presentation, you talked about heavy sides and the skin effects on telephone lines. So I'm not really sure, but I thought the skin effect didn't really apply to audio frequencies.
Yeah.
So where did the skin effect and all that SNE come from at audio frequencies?
Well, the skin effect is based on the fact that the magnetism is expelled by the metallic conductor, but the metallic conductor can only do that to so much of an extent, and the magnetism soaks into it. So every metallic substance has a time constant in which electricity can penetrate it, and that determines the skin effect. So if the wave reverses polarity or the telegraph impulse disappears, then that soakage has to start all over again. So if the pulses are of such a time duration that the electricity can only soak 1 millimeter into the wire, then you have the skin effect is basically given as 1 millimeter. So the more rapid the impulse is, the less the electricity can penetrate the metal, and the more reflective the metal comes, until finally the resulting current is all superficial and it's at the surface, and the metal inside never sees any electricity.
But this is not related to the heavy side condition, then?
I didn't quite get that.
So the skin effect is not related to the heavy side condition?
No, the heavy side, well, it is in a certain sense, because anytime you have resistance and conductance, that can involve the metallic part of the conductor, or the transmission system, I should say, which is called the conductor. And then those terms will vary with frequency and make everything extremely complicated. Otherwise, the heavy side equation is basically the relationship of all four factors. The two that represent the electric field in space, and the two that represent its destruction in the material substances, whether it be the dielectric or the metallic.
Okay.
So if you have a resistor, that's a device that's designed specifically to destroy electricity. And it does.
Just so we're clear, I'm talking about the heavy side condition.
Well, the heavy side condition
about
balance?
The heavy side condition, not the heavy side equation. Yeah, about balance.
Oh, yeah, the heavy side condition is that the rate of energy dissipation in the conductance equals the rate of energy dissipation in the resistance, and then the two exponential waves match, and then the whole relationship becomes frequency independent. And there's no distortion. In other words, the magnetism and the dielectricity are now propagating at the same rate, so they don't split apart and make the wave itself like a wave, crashing onto the beach. It falls over on itself.
That's a really neat analogy. But what I meant is that condition is unrelated to the skin effect, or it's related if the frequency is high enough?
No, it's related to the relationships between all four quantities. The skin effect is only an aspect of that. That's not directly involved, but in the end it's involved because that's the resistance term. So if the skin effect causes a variation of resistance and frequency, then the condition of balance by the heavy side condition then can only be realized over a certain range of frequencies, and then another range of frequencies it will no longer be valid. This is the thing that makes wireline transmission so difficult for broadband type of applications.
Okay, because what I'm trying to understand is in the presentation you referred to these graphs that had this D on them, and the implication there was that around this D, telegraph transmission and voice transmission lost fidelity.
Yeah, if you don't have a balance, if the heavy side condition's not met, then all the frequencies end up at the other end at different times, and then you've got garbage. So if you lay your arm on the piano keyboard so it makes simultaneous tones at the other end of the long-distance telephone line, it's going to start with the high tones, and then it's going to go down the scale like you're taking your finger and running it down the keyboard.
Okay.
And that's an undesirable condition. That condition disappears if the rate of energy consumption in the dielectric is equal to the rate of energy consumption in the metallic. And then the reason that I bring the heaviside condition up is that can be transformed into complex induction in space, where instead of resistance you have leakage inductance, and instead of conductance you have leakage capacitance, and then you end up with a similar situation, and there's no propagation velocity or anything that interferes with the impulse, and then you can transmit an impulse from one end of the transmission system to the other with absolutely no time delay.
Okay.
So it's not really the easiest thing to say in words, and it's pretty difficult to express mathematically. But that's basically what I was getting at, was the original heaviside condition is one for time, but there's also a heaviside condition for space, and if you build a transmission structure in which the leakages are equal on both the magnetic and the dielectric, and the mutual factors are equal in both the magnetic and dielectric, it cancels out the propagation velocity, and there's no phase delay from one end of the transmission system to the other. It appears to be instantaneous.
That's actually getting to the next question I was going to ask with respect to the Alexander system. And you talk about this long transmission line which has instantaneous propagation because of the coils and the dielectric structure. So is the system just launching a plane wave into the ground by sending it into the ground simultaneously at all these different points?
Yeah, the Alexanderson antenna uses the principle that I just described to cancel out the propagation velocity, so all the ground terminals are operated uniformly, but the principle did allow for creating any velocity you wanted so that you could skew the wave by either making it go faster than light or slower than light to get a directive characteristic. But when the propagation is completely canceled out, the antenna tends to transmit in all directions, and that would be straight down into the ground and straight up to the ionosphere. There's no electromagnetic wave to speak of, even though it was advertised as an electromagnetic radiating system. When you do the calculations, like at the end of my lecture there, when I presented the calculations, you'll find the electromagnetic component is usually only a fraction of 1% of the total electrical activity of the antenna, so it had to be propagating by another means. And the experiments I've been able to do with such structures indicate that that's indeed what it does. It propagates in a dielectric manner into the interior of the Earth.
Okay, so you just said something really interesting there, which is that the wave is propagating also up into the ionosphere into space. Is that a dielectric wave propagating through space, or that's some other wave?
Yeah, that would be basically a displacement current flowing from the elevated transmission structure, which is not really so much of an antenna as it is a transmission structure. The capacitance between that and the ionosphere will produce a displacement current, and then on the other end, because of the conductivity of the Earth, there'll be a conduction current, and the two will normally be 180 degrees out of phase. Now, in the Tesla system, they're 90 degrees out of phase, and that makes a big difference. So that means one current exists while the other one's dormant, so there's no circulating current. That's the advantage of the Tesla system over that of Marconi or Alexanderson, is there's no possibility for a closed current loop. And then you do definitely have an electrostatic transmission. The lines are not shunted, but they have to propagate.
Fascinating. Can you talk a little more about the broadband network you developed for this?
Well, that again involves the heaviside principle, where I balance out all the forces, and then the Alexanderson structure behaves over a broad band rather than operating on one frequency. So it's very similar to building like a bandpass filter. Normal electromagnetic structures can be represented as a low-pass filter. Well, they're pass certain frequencies up to a point, and then they'll fail to transmit past that, and then a high-pass structure is more like the longitudinal type transmission where the higher frequencies will propagate, but then past a certain point going down, they'll fail to, and if you take those two curves, depending upon how you configure them, you can have a bandpass characteristic of any width you want. The way Alexanderson and Tesla configured their systems is they were designed to be resonant at one frequency and optimized for that frequency, and there was no possibility of operating the system over a broad bandwidth. That's their main drawback.
So let me see if I got this straight. It sounds like you're saying a broadband network is I guess what you call your analog computer for dielectric waves in parallel with an ordinary transverse analog computer equivalent. Is that right?
Well, what you can simplify it to is I'm taking the electromagnetic wave and the magneto-dielectric wave and causing them to balance each other out in a similar manner in which the equal losses in a telephone line and the Heaviside criterion will result in a cancellation, and then all of a sudden the phone line will operate over a broad bandwidth, where normally a telephone line is a low-pass network.
That's really clever, but I'm still not quite understanding. I thought the whole key to the Alexanderson principle was that you were operating in this magneto-dielectric mode. So what does adding the electromagnetic mode to the system help?
Well, the two cancel each other out, so there's no propagation delay on the transmission structure, so it's uniform, so it doesn't feed back on itself and short the lines of force from one end to the other. And then also, the way the network is configured, it becomes monopolar. So in my situation, then you have transmission strictly into the ground, and all other transmissions in the space no longer exist. There's just one pole in the transformer, the neutral terminal, and that connects to Earth, and that's how the Tesla system worked. The Alexanderson system wasn't quite that advanced in its original conception. I had to make improvements on it.
That's really cool. Does anybody else have any questions? I feel like I'm monopolizing this again.
Oh, please continue with your questions. Good question.
Okay. So you talked about how there's no Schumann resonance in the presentation. If that's true, why is it possible to measure a 7
Yeah, that was my question as well.
frequency?
Well, that would have to involve the whole Earth and not just that tiny gap between the Earth and the ionosphere.
Yeah.
So what I determined at my hobby research facility with a dual balanced antenna system involving a Beveridge and an Alexanderson is that most of the signals that are attributed to the Earth ionosphere waveguide in actuality do not originate in the Earth ionospheric waveguide. They originate from the interior of the Earth, which in my view is most likely hollow.
Okay.
So what appears in the ionosphere is basically is just a refraction of what's going on in the Earth, and then there's a crossover frequency of about 18 kilocycles, where then signals start to become more in the ionospheric mode than in the telluric mode. So if you want to transmit in the ground, it's better to do it below 18 kilocycles, and if you want to transmit through regular space, it's better to do it above 18 kilocycles. And at 18 kilocycles is the nodal point where there's a crossing, and that's what shifts before a major earthquake, and that's one of the means that I determine the onset of a major earthquake is the shift in that balance frequency.
So you're saying that there's some fundamental geometry shift in the Earth before a major earthquake?
Yeah, that frequency will drop.
nodal frequency?
It'll very quickly descend to about 9 kilocycles, and then the signals will become much more coherent, and then it slowly descends past that point, and the electrical activity starts to rise really sharply. And the signals become stronger and stronger, and the noise impulses become stronger and stronger over a very broad bandwidth up to about 15 or 20 megacycles. And then once it goes into a full resonance mode, somewhere between 400 cycles and 2,000 cycles, the blast is imminent, usually within 4 to 8 hours. The whole process takes about 3 days.
So, one of the things that you said in the videos about the earthquake detection project was that you detected the Fukushima earthquake a few days in advance from the ionospheric reflection of the telluric signals.
Yeah,
that means that just
the signals were so strong.
Go ahead.
Go ahead. Yeah, go ahead. Keep on. Hello?
Hello?
Yeah, go ahead and continue your question. I hear you.
Yeah, go ahead and repeat your question.
Okay.
Yeah, go ahead and repeat your question.
What I was going to ask is, does this mean that anybody can build their own receiver which would predict an earthquake somewhere around the planet a few days in advance?
Yeah, it's not difficult, as long as you want to sit by the speaker 24 hours a day and determine the signals. The thing is, you have to be able to determine distinction between the 4 signals that are produced in this situation. One is from hurricanes, the other is from earthquakes. They exist as one pair. And then one is from tornadoes, and the other is from volcanoes, and they exist as another pair. So rather than limiting yourself to just the ionosphere and getting the noise component and having no sense of where the thing's really coming from, the simplest thing to do is just use a potential differential method, which is extremely susceptible to interference, but if you put a low-pass filter on it to get rid of all the Navy stations and a high-pass filter to get rid of all the power line noise, that's becoming the main complication right now. The power systems are being wired incorrectly and transmitting harmonics into the earth, but then all you need is 2 ground rods about 1,000 feet or 2,000 feet apart, connected to a very high-quality audio amplifier, and put it into a loudspeaker and just leave it on all the time.
Have you ever thought about publishing plans for this device? I guess there's no plans, come to think of it, are there? They're just
no, I mean, it's something any experimenter can do. The main problem you're going to have is fighting interference. So with the way the power systems are wired these days, reception will be absolutely impossible because of all the stray power line harmonics, rivers of them flowing through the earth right now. So the Alexanderson principle phases those out. So you can phase them out because the Alexanderson system is no longer sensitive to any type of transverse propagation like currents flowing, along the surface of the earth. It only responds to currents that are flowing radially into or out of the earth. So if you're in a nice quiet location and there's no power lines around, or if you're lucky to be in one of the few places where the power companies are not sabotaging their electrical systems and turning them into interference generating and EMP receiving systems, then you'll hear these sounds. But like I say, you're going to have a lot of other interference complications from Navy submarine transmitters and stuff like that. So you'll have to have a very good filtering system to cut out all those higher frequencies. So that's usually, the cutoff is usually selected as 15 kilocycles. So the first system that detected the Landers earthquake, which is where the station was built, was in Landers, which was convenient, was basically 1,000 feet of field telephone wire with ground rods driven into the center of a type of bush that has a root that goes down about 150 feet, And then that went through a network to eliminate as much of the power line noise and the Navy noise as possible, and then it went to a PA speaker system around the property, and there was a lot of Coast Guard interference and Navy interference and power line interference, and but the guy that owned the property, he loved the sounds of all that stuff. He wouldn't live any other way, so it didn't bother him, so it was just left on all the time. And then him and another associate of mine there witnessed the whole evolution of the Big Bear Landers earthquake pair from its frequency standpoint, from inside the Earth. Then later on, I developed a more advanced antenna to cut out the interference and get much better fidelity of the impulses coming out of the ground. And then that went through a fancy network system of analog computers that extracted the various signals and then directed them to chart recorders. So that way, then you didn't have to be listening to it all the time. And then the chart recorders were paralleled with polar relays so that if it reached a certain threshold, then it closed the switch and activated an alarm.
So you were basically using your longitudinal transmission line simulators as sophisticated filters.
Yeah, I didn't get the last two words.
So you were basically using your longitudinal transmission line simulator devices as a sophisticated filter.
Yes.
Cool. Also, one more thing that I was still not quite clear on with the Alexanderson system, it requires a multiple ground point array by definition, or could you do it with one ground rod and one section?
No, it definitely involves a distributed lineal configuration of grounding points.
So it's a type of phased array then, basically.
Yeah, similar. So it's kind of anti-phase. It all works together. There's no propagation delay. So that increases the antenna aperture. And by not just using a pair of ground rods, then that rejects any transverse component, such as power line currents flowing from one point to the Earth and the other, and pretty much restricts the receptivity of the antenna to the radial component that comes from within the Earth outwards or from outside the Earth inwards. So it kind of makes a 90-degree turn.
Okay. You talk about this instantaneous propagation along the antenna array. But in between these different tuning points, you said in the talk that it propagates inside the transmission line at just below the speed of light and above the transmission line at just above the speed of light.
The whole idea is your loading networks cancel out what residual electromagnetic propagation you have left in the open wire structure. But the distances between the loading networks are so small that, and the frequencies are so low and the wavelengths are so large that the electromagnetic component is already negligible. So you only have to add a few percent to the loading coils to cancel that out. The bulk of what's going on in the loading coils is the actual transmission process itself to produce this type of monopolar and time invariant wave propagation.
Because I guess the question I'm trying to get at here, it seems to me there's a difference between the signal appearing to propagate the length of the antenna instantaneously and the electricity actually propagating instantaneously. I can tune an antenna so that it will, with enough stubs and that stuff, so that it looks as if the sine wave has a 0-degree shift at certain points along the length of the antenna, but I'll be using a normal electromagnetic propagation along the length of the line.
Well, the lines not only are electromagnetic, but there's a number of lines, so there's a mutual component, so that the propagation on the lines is a little more complicated because there's a number of them, like, the number of turns on a transformer.
Yeah.
So,
I'm trying to understand, is the signal actually moving is the signal moving faster than c, or is it merely appearing to move faster than c?
Well, there is no speed. That's the whole thing. In my system, there is no speed. The whole thing cancels out. Now, according to theory, if I was to provide, an impulse or a step to one end of the line, I would still be plagued by, the electromagnetic component of the transmission lines, slowing that down to the velocity that you would expect, which would be slightly less than that in light. But once the thing builds up into its mode, in other words, once the wave has filled the thing and the reflections all cancel each other out, then the effective propagation velocity is instantaneous.
Okay, that's what I was trying to get at. The step
Yeah.
propagates at normal speed, but it appears to propagate faster than the speed of light, or instantaneously.
Yeah. So that's all dealing with theory, because these things are a little difficult to measure. But it's on a common sense level that if you have a wireline transmission system and propagation is parallel to the direction of the metallic conductors, then the charging process is going to involve that element, and then the loading sections will appear transparent to the impulse.
Okay.
So there's a similar situation. We can take a regular loaded telephone line where H loading is every 6,000 feet. There's 88 millihenry coil put in the line. Now, if we take a 15-mile long line of that and we measure the time delay, we'll find out that the propagation velocity is about a tenth of that of light. But if we measure the actual propagation velocity in the wireline structure, then we're going to find that it's going to be more like 50% the velocity of light, or 80%, or depending upon, if it's in a cable or open wire or what have you. So even though the signal takes a long, long time to get to the end of the 15 miles from the respect of the propagating velocity of the telephone cable pair itself, the addition of the loading coils produces an effective velocity that's long, but the actual velocity in the wire sections is still the original velocity of light for that transmission structure, with paper and the surface of the copper and all that dragging the wave down to a fraction of the speed of light.
Because that's a really important point that I think doesn't get enough attention in all this. But speaking of the structure between the wires of the Alexanderson system, you included a little diagram in the presentation of the field circulating. Now, in one of your other lectures, you said that the Alexanderson structure could maybe, possibly, theoretically, teleport someone from point A to point B. Now, normal transmission lines don't teleport anything. So what's actually going on in this Alexanderson antenna that could theoretically do that?
There's a field around it, and it's a space scalar field. So if it's space scalar, then there's a possibility that an exactly proportioned structure at some other point in space would respond to that instantaneously, and there's a fantasy theory, I wouldn't regard it much more than speculative, that somehow there would be a coexistence in those two spaces for a physical object in one and or the other. But that's highly speculative.
Okay.
But something to keep in mind is there always is some kind of possibility that some kind of transmission network possibly exists, like the Integratron that Van Tassel tried to build, where two of those would be basically a combining of two distant points in space into a uniform point by circumventing the dimension of space altogether. But that's getting into, wild theory. I can't justify that with actual, CGS.
If I take two boxes of if I take two boxes of the exact same size and shape, I don't get objects teleporting from one box to the other. There's something else going on there.
Yeah, well, this is a little more advanced than that, because you're dealing with an electric field. An electric field involves a process of the ether, and then once you're getting in the process of ether, then you're one step away from the process of creation.
So, in your view, would the ether hold energy, or is it just a construct?
Well, the ether actually stores energy and momentum. So when you have an object that appears to have physical inertia, that is not due to the inside of the object, that's due to the field around the object. That's what provides the momentum to the mass. It's not the mass itself, it's the field that the mass bounds. So if you were to take that field away, there would be no inertia, and any physical object could be brought into motion or brought to a standstill with no time constant. It would be instantaneous. This was demonstrated in the mathematics and experiments of J.J. Thomson, and later led to the concept of relativity and other things to try to explain it in some other fashion that Thomson didn't necessarily agree with.
I'm actually running a little low on time. I just wanted to mention my point. I'm actually a biologist by training. I seem to have stumbled into this randomly, but there's one thing that I'd like to mention to you. Maybe it will perhaps change your thought on something, or in regards to how you started with in your four quadrant theory, going back to Pythagoras and looking at a lot of ancient geometry. Recently, it was published that pi can be algebraically expressed. So that would actually change a lot for trigonometry, and I would imagine it would change a lot for electrical engineering. So I'm wondering if you're aware of that, or if this is published in 2014. I'm wondering if you are aware of that.
No, I'm not. I haven't heard of that specifically, but I know that pi can be derived from an infinite series. So it can be derived in a form of algebraic expression and not geometrically by the use of an infinite series. And I think I actually published that series in one thing or another. I think the book I have coming out on polyphase geometry and Versor operators actually gets into that. But there's a lot of books that will give you the infinite series for pi. It's actually the sum of two infinite series together, just like an infinite series will express a sine or a cosine or a hyperbolic function. So then it can be dealt with more algebraically and not geometrically. So maybe there's been an advancement on that I don't know about.
Yeah, pi is equal to the 4 divided by the square root of phi. That could be proved many different ways. So that would essentially make the current value that's accepted for pi wrong by 0.03. So about 3/100ths, if you will. So there are people in NASA that have confirmed that they've had to change the value of pi for their long-range satellite trajectories, probably not knowing why, other than the fact that the Archimedes principle, which basically takes the sum of infinite polygons within a circle, creates essentially a area underneath the curve, which is, I think you've alluded to, even in calculus itself, which creates an approximation to a value and not the true value itself, making it difficult and making it a transcendental number. So therefore, it's not able to be expressed algebraically. This new finding...
Yeah, no, I don't know. I mean, it seems like, pi has been determined experimentally enough that if there was that big of a percentage error, somehow it would show up, but I don't know. That's kind of I'm getting out of my field there. But if anything that has a square root of 5 in it, that's a golden ratio situation.
Right. So pi can be expressed as the square, as a relationship between the golden ratio and the square that inscribes the circle. So anyway, I'm only bringing this up because I would really like to see some of the math, because in the lectures that I've seen from you, and you've become kind of famous on the internet by another video that you've mentioned. That's a mention. I'm not sure if you've heard of it. It's an ancient wisdom video out there on the internet on YouTube. You're on it, and anyway, you mentioned a lot of limitations on the current math to understanding what you've engineered and what you've seen hands-on, experience-wise. The theory doesn't match up, and I'm wondering if this can help. This finding can maybe create some harmony in some of the equations that don't model what you're seeing. So I hope that in the
future... Well, I can't say, because I'm not really a mathematician. I'm an engineer. So
Yeah, yeah.
So, and in that situation, most of the mathematics that I present, I've had to develop myself because the mathematics that's available is not particularly useful for these applications that I'm putting it to.
There's a new math that's coming out. It's a new old math, if you will. It solves a lot of the problems with our math, and I don't know. I'd like to see some more of your math. I hope that you do release some more of your math. I'm going to continue to study your work, but I believe that what's happening, there's vortex math. Obviously, you've heard of the rodent coil, maybe. There's a lot of things going on this year mathematically that are changing a lot of our perceptions, and I think they're going to make the equations that we use much simpler to understand it and more harmonious. If you're including obviously the golden ratio, it seems to me that says a lot.
Yeah, well, what I have coming out now is probably one of the most involved mathematical writings I've ever produced on this Versor algebra. So that should be available shortly. It took me about a year to put all that together, so I think it'd keep anyone busy that wants to deal with this particular mathematics that's utilized in engineering for polyphase power systems that the theoretical basis has never really been developed for, and no engineer understands where it came from or how it relates to more common forms of so-called geometrical algebra. So I'm rather proud of that work, and it also tends to lead back to a Pythagorean understanding with regard to polyphase systems. So otherwise, I only have so many hours and so many days and so much, impetus and interest and whatever. I'm about ready to go insane right now over, the labor of the 4 or 5 things that I'm working on. It's just completely overwhelming. I'm producing hundreds and hundreds of pages every week, that distills down into within 100 pages of writing. And I'm committed now that I gave this presentation, which is jam-packed with more material than could ever be talked about in 4 hours, and I have to put this in book form, and it's going to be a big, big project. So I'm engaged in that now. But I can only do so much, and at my age, I'm starting to lose interest, and it doesn't matter anymore because the world's taken the big shit around me, and all the institutions are failing, and I can't get parts. I can't do any experiments anymore. I'm stuck with mathematics. So I only have so much steam, as one individual that's been doing this since he was 6 years old.
Thank you for all your work. I'm 30 years old.
Thank you.
I'm 30 years old, so I want you to know that this will continue, and I hope that we can talk again. I actually have to go because I'm at work right now, but I really appreciate everything that you've done, and I want you to know that there are people out there that are going to take this even further, and I hope to be able to speak with you again. Thank you. Bye-bye.
Okay, you're welcome. Well, everybody can, write me at Lone Pine, and unless it's too crazy, like the one I got recently, that the sun's flat on one side and the ionosphere is made out of glass, and the person that wrote the letter was Jesus Christ. Well, he gets the postcard of the coyote, but most people get an answer to their question.
There's a funny story about the letter. He actually made a YouTube video talking about it, sending it to you.
Okay, well, I don't know that much about it because I live in my car.
Yeah, no. Anyway, you said something really interesting a few minutes ago about the electric field being a process of the ether, which is one step away from the process of creation. I assume that's getting more to the cosmic induction generator.
Yeah, well, I mean, it's a sequential situation because you start with the archetype, and then the archetype evokes the formative forces. The formative forces act on the primordial ether, and then the process is material creation. It's very basic. You can go one way or the other way on that chain. And the ether is kind of the first step into actual materialization or creation, or going the other way of dissolution or destruction.
That's really eloquent. I don't really have anything to ask about. That kind of sums it up.
Yeah, I don't know how I arrived at that. To me, it came to me as some kind of commonsensical thing, I think, in the four-quadrant presentation, which took a lot of inventing on my part. That was quite an effort to put that together.
But to get back to more technical things, in the presentation you talked about having two generators, one in Los Angeles and one some distance away, and how if one of them gets 90 degrees out of phase due to the length of the transmission line between them, then the one generator can't see the other. Now,
yeah, no fall out of step.
It seems to me that but if the delay is being caused by the transmission line, isn't it going to cause that delay in both directions? They can see each other as if the transmission line didn't exist.
Yeah, it's kind of like that, or you can look at it, the total delay going from the sending generator to the synchronizing generator back to the other end is 180 degrees. So they're actually in opposition to each other. But the synchronism is lost at 90 degrees, and the machines basically are operating independently of each other, and if they lose synchronism, then you get a wandering phase, and then it will short out the power line.
So this loss of synchronism isn't necessarily caused by the wave arriving late, but by the fact that when the generator at the opposite end sends something back down the line, it arrives with that extra 90 degrees delay.
Yeah, and then it's in opposition. What happens is then the two machines start to fight with each other, and they go into oscillation of what's called hunting, and then that'll trip the circuit breakers, because you'll have a succession of short circuits as the generators pass through opposition.
Okay. Thanks for clearing that up.
So what the power companies do is they use the Alexanderson principle and put mutual inductances in parallel across the line, and then that cancels out the effects of the capacitance of the line and leaves only the inductive reactance and the resistance to contend with, and then there's no time delay, and then the two rotors can operate in synchronism, in step with each other without the delay. But that introduces a transient when you energize those inductances on the line and causes a lot of circuit breaker blowing and other complications that some of these utility engineers don't quite seem to grasp.
Interesting. Can you talk some more about the two different kinds of voltage and current? This is something I've never heard about before. I think normally voltage is something that you get when you put the voltmeter across the battery terminal. The current is what happens when the current goes through a resistor or some other load. So there are actually two different kinds of current and then two different kinds of voltage.
There's a conduction current, which is the conduction current is materialistic, and then there's the displacement current is etheric, and then there's the electrostatic potential, which is materialistic, and then there's the electromotive force, which is more of the etheric, so they cannot be equated to each other. Even though the same dimensional units are attempted to be utilized, as the electromotive force is a result of the change in the magnetic field, and the displacement current is a result of change in the dielectric field. Conduction currents and the electrostatic potentials are more involved with forces acting on the metal conductor. So they are basically integrals or derivatives. I can't say right off the top of my head, but they're functions of the field that are not directly associated with it. So you can't really just put them together. I wrote a whole paper on that. Go ahead.
Yeah, I actually looked it up, and I couldn't quite make head or tail of it. Is it actually possible?
That's about as simple as you're going to get it.
So what I was trying to get an answer to a simple question, which is, can two different kinds of voltage coexist on the same wire?
Yeah, providing that there's a reason for them to coexist. So if the changing magnetic field is producing electromotive force, and that electromotive force is immediately causes an action or a force on the metal, physical force, then that's the potential. You can equate the two, but they're not of the same species. It's just that one has provided the means to the other.
Okay, so I guess what I'm wondering is if I have the tin can telephone across the way to my friend, and my other friend wants to talk on the same line, could he use the other kind of voltage to talk on the same line?
No, because you have both voltages on the line. You have the potential on the conductor, and you have the electromotive force for the magnetic field surrounding the conductor, so all you can do is superimpose on those.
So that result would be one voltage value.
Yeah, so a meter just gives you like the shadow of what's going on. You can't necessarily tell how that so-called voltage is coming about. It could be coming about by, a statically charged capacitor, which represents a potential.
Okay, but you could build
the force. Let me finish. Which is the force on the plates of the capacitor due to the dielectric field, or you could be measuring, the output of a transformer winding, which is electromotive force and has nothing to do with potential until it's applied to something where that potential can exert a force, like between the plates of a capacitor.
But it would not be possible to build a meter that would distinguish between the two types.
Yes, actually, there is. Electromotive force can be measured by a coil type of instrument, and the electrostatic potential can be measured with an electrostatic voltmeter, but then you're still not really separating them, so again, it gets into this chicken and egg situation, is each one becomes part of the other. I don't know exactly how to describe it, because the meter can't tell the difference between the voltage of a charged capacitor or the voltage of a, coming out of a transformer winding, which is then rectified to make it, appear DC like the charged capacitor. The meter can't distinguish between those two. But as soon as you put some kind of resistance load on it, well, then it becomes immediately distinguishable because one has a time constant and the other one provides a continuous current.
Okay.
So you'd have to use both a voltmeter and an amp meter, and you have to know the capacitances, and so it makes it very difficult to separate the two.
So I only have one more question here, which is that if you have a magnetic or a dielectric field on its own, not in a quadrature electromagnetic relationship, do they propagate faster than the speed of light, or slower?
That's a question that's yet to be determined. No one has actually measured the independent velocities of either the dielectric or magnetic field. They're both assumed to be the speed of light, but from a radial standpoint, there can't be any propagation with the dielectric field, because that means that the propagating lines of force would have to end at the wavefront in space, which they can't do. All dielectric lines of force have to terminate within molecular dimensions of some kind of substance. So that means that they have to kind of already be there, or when they form, they have to form uniformly, which leads to the theory that they form in counter space. But to actually get into the definitions and proofs and all that is an extremely difficult situation that no one has really penetrated into. And the mathematics gets kind of unwieldy also. So Steinmetz starts on the project in his Transient Waves book, but does not fully develop the situation, but the equations that he provides is when you rationalize them and remove 1 over the speed of light squared as a dimensional coefficient, there is an independent variable for the velocity of propagation of the dielectric force, and there's an independent variable for the propagation velocity of magnetic force, and then that could be determined experimentally. And it might turn out to be, in the case of the dielectric, that coefficient is not a velocity, but a counter velocity or some other dimensional relationship. So it's an extremely complicated situation that probably would need several people to work out, because my mathematics ability tends to be somewhat limited. If I had any help from anybody and cooperation that had advanced knowledge of differential calculus and all these things beyond what I have, then maybe some ground could be broken on that. But then that becomes another 1-year project. That's the complication. I only have so many 1 years, and right now I got a very heavy 1 year of trying to build this antenna system for the telluric transmission so that I can actually physically demonstrate the structure and make it engineerable. It can be duplicated. That's the primary objective right now.
Thank you for your effort.
The other primary objective is writing the book that goes along with this presentation. That's a full-time job that and try and keep my car going.
Yeah, what I guess I'm trying to get at with my question is, if you have two Alexander structures on different parts of the planet, or two Tesla wireless stations, the signal goes from one station to the other instantaneously. There's no velocity.
That time the signal was all chopped up. I don't know.
So what I'm saying is, okay, if I put a Tesla station or an Alexanderson station in New York, and I put another one, the propagation time from New York to London is instantaneous with a Tesla or Alexanderson electrostatic transmission.
Well, that has to be measured. That's one of the reasons why I'm trying to get one of these things back up again. No one knows that. Ultimately, all this has to be determined by experiment. But every time I build something, it gets destroyed. So that's the complication. I made a bid for the clowns that got the Wardenclyffe Tesla site there in New York to, allow me to build a scale model of that so that it could actually be put into service for the maritime business or the Navy, and then actual determination could be made of, the depth of penetration through the seawater to submarine, or also the propagation delay or advance between that station and a similarly constructed one overseas. But, this is not something that I can really do, living in my car trying to survive on Social Security and handouts that I receive in the mail. It's just not happening. I'm doing all this myself. And I've already done it the number of times I built these things just to have them destroyed when they're completed and nobody came to my aid. I can't go back to RCA for more parts. There is no more RCA. All this stuff's gone. The Orientals have gone nuts over the value of it and have completely inflated the prices for all the tubes and parts beyond anything. So somehow some group or somebody has to overpower this and make the experiments. I'm just doing what I can in the front seat of my car.
Well, thanks for doing what you can. This is very interesting. Does anybody have any other questions? I'm out.
Yeah, Eric, this is Patrick. Stein, you say that Steinmetz, in his book, he says the idea of electrostatic charge is really a mind virus that's destroying, correct calculations. Would you elaborate on that? I don't understand that. I come from a physics background at a top university, and we were taught the, traditional things that are being taught now about electrostatic charge. So this is all new information to me. Can you elaborate on what Steinmetz meant or how you interpret what he said?
Well, the electrostatic charge is just a shadow of the dielectric field. And it tends to equate electricity with mass, which is erroneous. Electricity is not a process of mass. If mass gets involved, it usually ends up consuming the electricity with some kind of physical force involved, such as motion or heating or whatever. So the dielectric field is in space. The charge is just a surface projection of that and is not a thing of its own, but the physicists, particularly with the advent of relativity, have erased the electric field from the equation and put it strictly in the terms of mass and charge carriers and all that, but those are secondary things. So it's like, I can drive through the snow and leave tracks, and the physicists will say that my car doesn't exist, but the tracks are what has happened. Where Steinmetz is looking at the actual thing that's making the tracks, which actually was fairly well understood in this time until the modernists hashed it all up into this materialistic philosophy of electricity and ran off in their own direction with it. And the situation is going to lead to the entire collapse of the electrical system of the country, because these engineers all believe in electrons and not the field, and they have no idea of the Frankenstein they're creating with their electronic technician concept of electrical power.
So there was a way to measure the field without recourse to the pinpoint charge, right?
Exactly. There's a field density and there's a field tension and all of these things, but you can't get into the field to fool with any of this stuff. You have to use some kind of material means to get access to it, and that's what gives rise to the so-called charge and the so-called current, but those are just shadows. They're secondary things. They don't represent the field itself. So the complaint that Tesla made is, to quote him, is, we have no conception of electricity without the intervention of gross physical matter. That's what we're up against in trying to understand electricity. So it makes it more important to focus on field concepts and geometries and situations like that, and get away from atomic dimensions and particles and those type of things. That's what I'm trying to do, is to move it back into purely geometric consideration and deal with it as such.
Yes, sir. So as soon as you introduce mass, what happens to your thinking and your calculations? Is you become too localized in a certain point, or you're too dependent on the idea of electrons, and that screws up your thinking about how to picture the whole process? I mean, what is the problem? What
happens is you're looking at a secondary effect and not the primary cause and means of the whole process. You're just looking at the residue and saying that the residue is what's going on, but the process and the geometries are non-existent. Now, within the realm of physics, as far as gravity goes and things like that, those conditions might be important, but in electricity, they're not. Mass and charge have to be eliminated from the dimensions and units, and that's something I've done, and once you do that, everything becomes very simple. Once you develop a new system of units that's electrical and not physical, which I've done and have advertised extensively and written about, then all of a sudden everything makes perfect sense, and calculation becomes very easy.
Are you going to put that material in your new book, or is it already out there?
Oh yeah, the new book is going to be complete. It's going to be a real effort to put this whole thing together. It's really, the time has come. I know enough now. I have enough experience, and this thing started the whole subject off. I'm going to have to go from beginning to end on this. It's going to take about 2 years.
That's great.
To write the book?
Yeah. So it'll come out in installments, because there might not be anything left in 2 years. So at any rate, to wait that long, I don't have faith that this society is going to make it through the decade. So anything that takes longer than 6 months or a year to do, I'm not interested in from a certain standpoint. So this will be just like the alternating current math book that's coming out right now. That's in 3 stages. So for the people to edit all that and to formulate all the equations, from handwriting into whatever, for print and all that, and making all the diagrams is an absolutely massive effort, almost beyond that of writing the thing. So, and there's not really a lot of people helping with this, and there's not, a lot of money made available. So everything, moves along at this slow pace. But 6 month blocks is what I'm looking at. So a good chunk of this last presentation will probably come out in about 6 months. The handwritten versions of it will be transcribed and go out. I'm going to do it in the energetic forum like I have before, where I write this stuff in my car in the bushes, and then I drop it in the mail, and I found somebody to pick up where David Webster had done, and is going to put this out every 5 days. So the material will inch its way forward in that regard. So within 6 months or a year, good chunks of this stuff will come out. As far as the dimensions go and all that, I worked all that out in the Lone Pine writings. The Lone Pine writings are really the introduction to all this stuff we're talking about.
Okay. You mentioned something very interesting about the lack of our current power line engineers not understanding the fields and and you said a catastrophe can happen in our existing power grids. Is that due to some kind of interference between all these waves that are propagating that they don't realize are there? Or what's that from?
Yeah, that's basically what it is. Is they've created a power system where multiple modes of propagation are possible at a multitude of harmonics, some of them very unfriendly waveforms, and the power system is not rejecting these now, but it's magnifying them, and it's delivering them straight to the customer. So what's happening is the power system is basically turning into a giant antenna for nuclear EMP or solar eruptions or any of that type of stuff, and they're providing a metallic path for it all the way from the high side on the grid right to the ground terminal on your wall outlet. So the electrical system is becoming a massive antenna and a massive parametric harmonic oscillator at 180 cycles a second, producing a massive antenna current that's getting stronger and stronger. And one of my covert operation jobs is to figure out what the mind state is behind this, or the resistance to expressing the mind state, and to present it to the proper agencies. So I'll probably be starting on that in the beginning of next year, so that's another massive project. But it really disrupts my work because it creates all this interference, and it creates a psychological dismay of looking at this, because I'm third generation in this stuff, and, not alone the shabby construction and the ugliness of the materials, but to see everything wired completely wrong is kind of a smothering effect on me. So I'm committed to write on that subject. In fact, the Versor algebra book that's coming out, what initiated the writing of that is, before I go into head-on combat with the power companies, is I never do anything like that until I reach a PhD level understanding of the subject, and then overwhelm all the people involved, so all they can do is then just shuck and jive afterwards and make fools out of themselves. So I'm pretty successful at that. But it's becoming, the society is becoming more and more resistant to criticism and reorientation. So at some point here, all that will become impossible. But it's going to be interesting to back this power company in a corner and make them say why they're doing this to the appropriate government regulating agencies, and it'll be fun. Somebody won't be happy.
Did the power companies take out some protective mechanisms that would have prevented some of this resonance?
Yeah, basically, there's no longer any ground fault protection. That's the first complication. Okay. There's no possibility of relaying to eliminate, if one of these waves gets out of control, or if you got massive currents flowing into the ground, burning somebody's house down with the wire laying on it. Originally, the power systems were configured that current flow could not develop beyond a small level, or if it did, it was cut off within 3 or 4 cycles. But the way the system's configured now, it cannot distinguish between a load current and a ground fault current, so it continues to burn.
Wow. Is there anything?
And then the zero sequence harmonic wave that's being generated in the system will not appear on any of the meters. So you can have 180 cycle, maybe 250 kilovolt ampere or 500 kilovolt ampere wave flowing in a power system, and the meters will not pick it up because it cancels out.
And they don't try to.
Is there anything we can do to protect ourselves?
Never happened before?
No, the systems are all used to be hooked in delta. So there's a delta connection shorts the zero sequence current out, and there's no path to ground. So the path to ground to drain the system is derived by a smaller grounding bank, which has an impeder in it, so that the fault current cannot reach significant values, if even a few amperes. And if there is a fault current in that line, then that goes to ground off the balancing or the draining transformers, the grounding transformers, then that relays the system out. But the way the system's configured now, it can't relay that out because the transformers are Y connected and they're solidly grounded, and the system has a neutral or a fourth wire. So any current flowing from line to this multi-grounded neutral is the same as a current flowing from that line to a wire laying on your car or it hit you or something, and it cannot distinguish the current. So the power companies are deliberately rewiring the entire power grid from delta to Y in a retrograde manner, which is costing them a lot of money. So the question is if it costs them money and it decreases the efficiency of the system by about 3 to 5%, then what's the mind state behind it?
Yeah, exactly.
So all other electrical engineers that I know, that are my age and been around for a time, are all wondering what in the hell is going on here. And it's gotten to the point now where the power company will not even deliver a standard 240 delta service to my laboratory, even though I have that service and I'm paying for it. They will not provide me with a closed delta. They'll force me to pay them $30,000 to put in a 208Y, which is useless to me. I need 240 delta. I have to have an ungrounded system so that my electrical impulses do not get into the town's power system and start wiping out everybody's computers and electronic devices. Power company refuses to do this, and they will not say why. They're forcing it on the customer. Well, I don't know. I have to get in a fight with the power company. That's the first step, is I get in a fight with the power company, and then I pit the power company against the government, and then see which way it goes. And then if that's the case, so be it. Then I got to get a 480 volt Y, and then they're going to try to ground it or whatever. I'm going to have to defeat that, and then I have to, on top of that, I have to put in my own transformer bank, which will cost about $10,000 or $15,000 to go to the 240 volt delta that I need to run all my equipment. It's like, on the Navy ships, all the power is delta. All the big telephone company installations I've worked in, the big RCA stations, and it's all 3-wire delta with no ground. The ground is not there in the system because you don't want all these currents flowing around in ground and all that. You want the thing isolated. Particularly on a ship, because you don't want, a motor winding takes a crap and you get current flow to ground. You don't want that thing flaming out. The system just rebalances itself, and then you pick it up on the ground detector lights, and then the engine men, in charge of the switchboard will find out, what feeder that's on, and then isolate that ground. Meanwhile, everything still operates, and there's no damage to the motors. It's the same thing with the mining industry here in Nevada, where I'm at, these old mines and stuff. You've got 440 volts on knob and tube wiring, and half the time the motor frames are not grounded and all that. You don't want that connected to a Y system, because then if anything contacts one of the phase conductors, you get the full blast from line to ground. It's dangerous to start a fire or kill somebody or burn out your old. Some of the motors here in this town were actually made by Tesla in Westinghouse. They're that old.
I've got a similar...
So I don't know...
You hear me?
Yeah.
So I'm wondering,
You talk about the solar flares and the solar eruptions and things and their effect on things on Earth here. And I'm pretty sure you mentioned that they can create ground currents, and if there's a big solar activity, they can make various things happening in the system. Is that also related to the ground connection?
Yeah. So if you have line transformers on both ends of a very long line, and they're Y connected, which they usually have to be to drain the static off the line, but through an impeder. But if you solidly ground both ends, then if the sun induces a traveling wave of current by jolting the Earth's magnetic field, then that traveling wave is going to go up the neutral and then flow in phase on all three wires of the transmission system and then go down in the ground in the neutral at the transformer at the other end. And then what that current's going to do, even though you will not necessarily pick it up on the metering because it cancels out, in the metering, it will saturate the transformer cores, and then the transformer cannot develop any EMF, and it shorts the line. This is usually how the solar flares end up knocking out the power grid.
I see. So is there anything that we can do to protect ourselves from all this?
Isolation transformer. Okay, when the power comes into your house, you have to go through an isolation transformer to separate the metallic of the power company from the metallic of your house. The power company no longer provides that isolation to the customer. They hook you right to the high voltage neutral, which then has a mutual admittance to the power feeder lines, the stuff on the towers, through the YY connected transformer banks. So basically, when you put your hand on your washing machine or anything else that's got a ground connection on it, you're touching hundreds and hundreds, if not thousands of square miles of metallic transmission structures. You're connected to a giant antenna. It used to be the distribution transformer separated that ground loop, but current engineering practices bypassed the transformer, so now you are metallically connected to the entire power grid rather than just the wiring in your neighborhood.
Well, hey, Eric, we're getting on an hour and a half here.
Okay.
And has everybody pretty much got most of their questions answered? And we can always do this again when Eric gets back from Lone Pine. We can schedule, more calls like this. But is everybody pretty good with the call so far?
Oh, yes. That's excellent.
Yeah.
Okay.
Yeah, definitely.
Okay.
Definitely.
Okay, good. Well, what I'm going to do is we should probably go ahead and wrap it up. It's about 11:30. When I get a chance, I'll make this recording available to everybody. I'll just put it on YouTube and email out a link if you want to get so you can at least have a link to it. And I guess other than that, thanks everybody for joining the call. And Eric, appreciate your time for being on the line with us and answering everybody's questions. And do you have any final comments, Eric, on anything or?
No, not really. I mean, we've covered a lot of stuff, so that's good.
Yeah, if that's good with everybody, then we'll see if we can schedule something, maybe here in a couple weeks or something like that. But this call, I at least wanted to give everybody an opportunity who has the Extraluminal transmission presentation to, ask some questions and stuff, and we can, do different topics and, general Q&A later and everything. And so I guess we'll go ahead and wrap it up.
Well, one thing I'll point out is a lot of the questions can be answered by reading the material in the Lone Pine writings.
Okay.
And moreover, if you have no technical knowledge whatsoever and can't deal with the dimensionalities, basically you're going to have to find some way to kind of educate yourself to that level, which would be helpful because then you have a little better understanding of the terms and the dimensions involved. Otherwise, this stuff is all very, very, very abstract.
Yeah.
And I think that one of the best ways to do that is to get a hold of some assignments as more basic books, and even though they're literal seas of equations, if you just read the first 2 pages of every chapter, he'll probably be way ahead of any electrical engineer in practice today.
Okay. Do you have titles?
Good idea.
Steinmetz's best introductory book is called Impulses, Waves, and Discharges.
All right, I got that.
And then something else that could be helpful is the introduction that Heaviside gives in his electromagnetic theory.
Okay.
Like the first 20 or 30 pages.
Okay.
And you can probably download these free if on archive.org. You can select a text, like text and book search, type in their names, and you can probably just download the PDF. Most of those are scanned in by Google. But they're
another one that I recommend is J.J. Thompson's Electricity and Matter.
Okay.
And unfortunately, there's really nothing other than maybe what I've written that's more basic than that. So that's kind of the complication, is there's this kind of void or gap between no previous knowledge on the subject and a basic knowledge on the subject, and that is the part to overcome. One way to overcome that is to start doing experiments with coils and capacitors and become familiar hands-on with the stuff. I'll also recommend any Navy training publications for electrician mate or electronics technician. Navy education is always the best. It seems to have the ability to express things in an extremely basic manner and not occlude them with too much physics or things that don't relate. So I've always found that Navy educational material is very, very helpful in this.
How do we get a hold of that?
Do you have any suggestions?
Well, I don't know. I mean, I know people have done it. I guess it's just a matter of whacking on the Internet.
If you search Google for like Navy Electronics Handbook, that kind of stuff, and put in PDF, you'll see that a lot of these like ham radio sites and all this kind of stuff will have like a lot of links to a lot of those type of old manuals that you can just download for free in PDF. And for Lone Pine Writings that Eric's talking about, Eric's homepage is ericpdollar.com, the middle initial P for Paul, ericpdollar.com, and then there's like a books and videos link. And if you mouse over that menu option, you'll see Lone Pine Writings. And if you get it through there, then that helps Eric and EPD Labs out the most.
Okay.
Because most of the purchase goes to EPD Labs, about 70% for anything that Eric has written or any videos or books.
Okay.
So, okay. Well,
do you have any suggestions for?
Go ahead.
Go ahead.
One last question. Did you have any suggestions, Eric, for experiments you mentioned with coils and capacitors?
Yeah, I mean, you can start with a basic DC power supply or some batteries and some amp meters and voltmeters, and then get some old transformers from the junkyard and some capacitors and stuff, and get some kind of variable AC supply and some AC amp meters and what have you, and start energizing these transformers, and maybe take like the cores apart, and play around with the coils by themselves and just become familiar with this stuff. Maybe try to build your own crystal radio set. I think that's probably one of the best introductions to the basic relations of dielectric magnetic fields, is build your own crystal radio for the AM broadcast band, and then you can go from there and try to make a vacuum tube one and experiment with some different antennas, put up your own wires and what have you, and just start to get that hands-on feeling so it's not abstract. It's very important.
No, it's actually very interesting that you mentioned that about the crystal radio. I was doing some research on the subject a while back, and apparently the best inductor for a crystal radio is called a spider inductor. It looks a lot like the Tesla coil you demonstrated in the Borderlands Tesla longitudinal electricity video. Was that a coincidence or was it intentional?
No, that type of coil will contain both the capacitance and the inductance, so you don't need a tuning capacitor, and then you'll be able to receive in the Tesla mode. I made a series on this in the energetic forum called the Crystal Radio Initiative that gives for the solenoid variety of the Tesla transformer, to incorporate that into a crystal radio set with the aim of actually receiving useful power from the AM transmitting station to vindicate Tesla's claim, and a number of experimenters actually did. They were actually able to run small motors, tiny little ones, off the energy that they received through the ground from the AM radio station. If to attempt that would give you a knowledge of hands-on with that subject, but you can just build a regular crystal radio out of the Boy's Book of Electricity or any of these earlier type of publications. I recommend getting as many of those as you can. Anything that was produced before like 1915 or 1920. And that big era of experimentation between when Tesla's work collapsed at Wardenclyffe to the advent of electromagnetic radio by RCA in 1921. So 1900 to 1921 was the heyday of the Electrical Experimenter. If you can find copies of Electrical Experimenter magazine or copies of The Electrician or the Boy's Book of Inventions or any of that type of stuff, that's really the best way to gain a good introduction to all this. All the modern stuff, including the ham radio books, is best to stay away from because they will misguide you.
Yeah, if you go to Google, search Boy Electrician. This is a 100-year-old book by Alfred Powell Morgan, and that's got a lot of these real basic experiments that Eric is talking about. I mean, it's designed for kids, and I don't have an electrical engineering background, but a lot of the stuff in there I can make. So, but the Boy Electrician, it's a free PDF all over the internet. Just type Boy Electrician in Google, and you'll see the PDFs.
Okay.
So, okay. Well, I guess we can go ahead and wrap it up. We're going on about an hour, 40 minutes now. It's 11:42. And so I'll go ahead and send out a link when this is up on YouTube. And then when you get back to town, Eric, just give me a call, and, we'll look at setting something up here in a few weeks or something.
Yeah, it'll probably be, we're committed to start the antenna project mid-October. So any weekend day during that interval will probably be fine.
Okay. We'll be in touch. And again, thanks everybody for being on the call, and thanks Eric for taking the time and being with us on the call. And
yeah, well, you're welcome.
I'll take care. You're welcome. Okay, thanks a lot, everybody.
Thanks for your time.
Thanks, Eric.
Okay, bye-bye.
Bye.
Hey, take care.
Bye, Aaron.
Bye. Thanks, everybody.